All right, here's a quick review on decimals for the comp test. And you want to, when you add, you have to have a common unit. So you need to line up your decimal point. So you have tenths with tenths, hundreds with hundreds, thousands with thousands. So again, kind of like money, you'd want dollars together, dimes together, pennies together, and parts of pennies together. And again, this happens at the gas station. So again, add, there's 9, 15, carry 1. So when I regroup, there's 5, there's 6, and there's 2. So, and you can estimate and say, well, if I add about, what, 38 cents to this, does that seem to be in the ballpark? And that looks pretty good. Subtracting, also, you need a common unit, which means you need to line up your decimal points so that that happens. Again, if you want to put a 0 here, you can to help you. Again, I can't take 8, so I ungroup. That's a 6, and I get 10. Subtract is 2. I can't take, this would be what, 9 dimes from 6 dimes? Or no, pennies, I guess. 9 pennies from 6, so I ungroup. And I add 10 to that. So there was 16 pennies minus 9 is what, 7. Subtract 1 dime minus 0, or 1 minus 0 is 1. And then on this side, I'm dealing like with money here, so that is 9. And again, technically, I suppose you could ungroup, but really not necessary. And again, if I take 10 minus $1 or something, I should be in the 9 range. All right, now, when you add and subtract, you're counting, so you need common units. When you do area, you're creating something new, area, volume, things like that. So you can just multiply, and in a sense, you can just ignore these and pretend that you're taking 28 times 36, but you're really making it, what, 1,000 too big, so at the end you have to compensate by dividing by 1,000. So this is 48, so there I get 12, what is that, 16, put a 0, this is what, 24, put a 2, that's 6, 7, 8, and what is that, 8, 0, 0. So 1, 0, 0, 8. And again, I have 3 decimal places, so I put it right there. Yeah, that doesn't look very good. So I put it right there. Again, this is 36% of 2.8, so you know it's going to be, half would be 1.4, so it seems reasonable. Again, if you kind of do it like this, you just multiply, so you get 48. 12, you get 16, 0, this is 24, carry your 2, that's 6, 7, 8, again, 8, 0, 1, 0, and again, since I multiplied by 1,000, I'd have to divide by 1,000, which would put my decimal right there. And again, you could do lattice on that too, I guess, if you want to. All right, division, I'm going to put the first number in the little house thing, and the other one here. I'm going to multiply them both by 10. Your goal is to get this to be a whole number, so I'm going to multiply this by 10 and that one by 10. So the decimal point goes there. 26 doesn't go into 6. It looks like it goes into 67 twice. And if you take 26 times 2, that's 52. So I'm going to subtract 52. What is that? Bring down my 0. 26 looks like maybe it goes in there, I don't know, 5 times. So what is that? 30, that's 130. So I'm going to put my 5 above there and subtract 130, and I get 20. And I'm going to bring down my 8. Let's see, what does it look like here? 26 times maybe 8. That's 48. I get what, 1620, and it looks like I'm going to be done. So I put my 8 up here and subtract my 208, and I'm done. Otherwise, if not, I'd have to keep bringing zeros down until I end up with a 0 right there. All right, that's a quick little review of decimals. And there's my final answer there. And again, oh, to check your answer, you have 67 cents divided by about 3 people. So it makes sense that everyone would have about 26 cents. So again, you have this, think about money, you have 67 cents divided by about 3 people. So as they split that money up, it should get smaller.